I apologize. This little box right here was at the bottom of page 150, but that's a mistake on my part. It really belongs at the top of page 151. Sorry about that. Okay, so what we want to do is we want to factor these completely. And these are for when the sum of cubes and the difference of cubes. So sum and difference of cubes. Now notice, sum of squares, remember, is prime, more or less, unless you can take a GCF out. But sum of cubes is not prime. But there's a formula for it. Now I'm going to say that for my students, and I'm assuming for most students, this is one of the very few formulas that we do not expect you to memorize at all. When I write exams, if I have problems like this on there, I just put this right in there, like literally right on the page, because it is not a formula worth memorizing, in my opinion, at all. So, but you have to know how to apply it. So what you want to look at is what's cubed and what's cubed. What's your A and what's your B? Because your formula is pretty obvious. It's A, let me type it in. There it is. Okay. All right, so let's look at this here. I need to figure out what's cubed to make my thing, right? So I have x cubed plus 27. So if I do that, A must be x and B must be 3, because that's how I'm going to get, here, let me put it this way. A cubed is equal to x cubed. That means that A must be, hold on. That implies that A must be equal to x. And B cubed is equal to 27. That means that A must be equal to, or excuse me, B must be equal to 3, because 3 times 3 times 3 is 27. Okay, so then you're going to use that in your formula. So where there was an A, oopsie, where there was an A, you're going to put x. So you're going to write, so x cubed plus 27 is equal to, parentheses, sorry, is equal to, parentheses, x plus 3, x squared minus 3x, because a times b would be 3 times x, plus b squared, which would be 3 times 3, which is 9. You're done. That's it, I swear. And here's a little trick. This guy right here in the back, always prime. Always. Never have to worry about it. Never going to go any further. That's it, right? So once you know what A and B are, you just plug in the formula and you're diggity done. All right. Now, I want to change B because B is too easy. I'm going to make this front number 250, not 2. Make it 250. That's a typo. Okay? All right. Now I'm doing that for your own good, I swear. Okay, so we're going to have to figure out what A and B are, and then we're going to have to do some other stuff. Now, before we can do A and B, though, you might be thinking to yourself, Alana, this does not look like a difference of cubes. What the heck is going on? Ah, you'd be right, but there's a GCF you can do on this. All right, so let's look at this. Is there anything that we could take out? Hold on. There it is. Okay. So I know I made it 250, not 2, but bear with me. So we could take a 2, an x squared, and a y, because, okay, this has 2 x's to give. This has 5, so the most we could take out is 2. And this guy only has 1 y, so the most I could take out is 1 y. And 2 divides into 250 and 128. Now if I do that, that leaves me 125x to the third. Look at that. Minus 64 y to the third. Look at that. It is a difference of cubes. It was just hidden in there. Crafty. All right, so now let's figure this out. 125x squared is my a cubed, and then 64y cubed is my b cubed. So we need to figure out what in the world this is. What cubed would make this happen? And then we'll know what our a and our b are. All right. So let's see here. Well, it's going to be an x, and this one's going to be a y. That much we know of, right? So what cubed makes 125? Did you say 5? Because it's 5, right? 5 times 5 times 5. So that means that a is 5x. And then what about 64? That's 4. 4 times 4 times 4 makes 64. So this is 4y. Now, once you know those two values, you've got it. You've got it in spades, I swear. Right? Now you're going to use the difference formula here, not the sum formula, because this one was a subtraction problem. So that's going to cause this to switch like this. And again, you don't have to memorize that formula. You do not. All you have to know is which formula to use when and to do it correctly. Okay? So our formula, because this one has a subtraction in it, see the subtraction right there? Right there. That means we're going to be using the subtraction one. Okay. So what we're going to do is, I'm going to put that formula right up here, just so we have it. Okay. If I could get it in there. There we go. All right, so what I'm going to have, let me pull this up. I'm going to have that 2x squared y business in front. That still's there. But instead of this 125x cubed business, let me have the formula. Oh, there it is. There it is. Okay. So I'm going to have a minus b. So a was 5x minus b, which was 4y. The minus and the pluses are all taken care of by your formula. So just make a and b positive, and then your cubes will all work out perfectly. The minuses is taken care of in that formula. Now here's where students make the mistake. You want a squared. So I want all of that a, all that 5x squared. So that's 5x squared plus a times b. So that's plus 5x times 4y, plus b squared. So that's 4y, all of it, squared. All we're doing is plugging into the formula for this part right here. The 2x squared y is just dangling in front, because we already figured that out. All right, so 2x squared y just sits there. 5x minus 4y just sits there. There's your a minus your b right there. And then all you got to do is simplify this. 5x squared is 25x squared plus 20xy plus 16y squared. And you're done. You're following that formula to the letter, literally, right? And don't worry about the minuses and the pluses. A and B are always positive. Just make them positive, and the formula itself will take care of the subtraction and addition stuff for you. All right, now let's do C. So C is a little bit weird because you're thinking difference of cubes. Oh, but it is. It is, I swear. So what it is, let's start with it this way. It's really n cubed, okay, n to the 6th minus p to the 6th. That's really a difference of squares. I know it seems crazy, but it's true. It's n cubed minus p cubed times n cubed plus p cubed. Now, if you don't believe me, multiply it, right? What's n cubed times n cubed? N to the 6th, right, because you add the powers. And then your outers is plus n cubed p cubed, n cubed p cubed. Say that 10 times fast. And the inners is minus at p cubed times n cubed. They're going to go away. They're going to cancel. And then your last will be minus p cubed times positive p cubed. And minus times a positive is minus. And it's p to the 6th because you'd add the powers. Okay. But these are differences in sums of cubes, right? The formulas right up here at the top of the page. So that means that all we have to do is figure out what A and B are, and we're set. And they're actually the same for both problems. Nice. So we learned A is N and B is P. That's it. So all we're going to do is literally write out that formula. So watch this. Okay, so this is equal to, all right, I'm going to write the formulas out, but instead of A and B, I'm going to write N and P. So N, did I do the subtraction one first? Yeah, I did the subtraction one first. So it's N minus P times N squared plus NP plus P squared. There's no numbers even on this one. So there's the first part. That's the subtraction one. And then you do it again. N plus P, N squared minus NP plus P squared. And you're finished. It might not be pretty, but it's there, right? All right. There's the sum and difference of cubes. And that's kind of a tricky one because it seems so crazy that 6th powers are actually cubes, but they really are. So if you change it with the squares, right, break it down to n cubed minus p cubed, n cubed plus p cubed, right? Then you break each one of those down. So like this one right here, let me do a little bracket for you to see. This one, little curly braces, is actually this part right here in the front, that part. That's the same part using the formula. And then the back part is the part without the bracket, and that's over here. Interesting now. There's the sum and difference of cubes. All right, we're done with that, and I'm going to pause right there, and I'll be back for the 5-step factoring strategy in the next video. So I'll see you then. Oh, but before I go, again, I just really want to reiterate, be careful when your A and B have numbers in them. Be very careful that you find those correctly, right? Make sure you square for A squared. You got to square both things. And then the 6th power one is just kind of a weird example, but I think it shows up in your My Math Lab homework. See ya.